Everyone, welcome back to my channel. Hope everyone is doing great. Let's solve today's Leetcode problem 3397, maximum number of distinct elements after operations. You are given an integer array nums and an integer k. You are allowed to perform the following operation on each element of the array at most once. Okay, either you choose to apply one time the operation, or you don't choose to apply at all. Add an integer in the range minus k to k to the element. Okay, for a given element, either you choose to add a number in the range of minus k to k, or you don't choose to add it at all. It's up to you. Return the maximum possible number of distinct elements in nums after performing the operations. Okay, we have to choose numbers from minus k to k for each element and add the particular number in such a way that the final nums will actually have the maximum number of distinct elements. Okay, and you have to return the count of those distinct elements. Okay, so here if you see, 1 has been added with minus 2, which will turn out to be minus 1. 2 has been added with minus 2, which will derive you to 0, and so on and so forth. After performing all the operations, we have this array which has all the distinct elements. As a result, we have written the length as 6. Let me go to this whiteboard. Okay, so let's try to understand the logic in general. Okay, let's assume that we have nums array which will contain elements from 0 till n minus 1, and we have been given an nk. Okay, for each element, okay, we have to choose in the range of minus k to k. So if the possible values for nums of 0 is nums of 0 minus k till nums of 0 plus k, this is the possible range of numbers which can be formed by choosing any numbers in the range of minus k to k, and this is the possible range of numbers which are possible for nums of 1, and this is the possible range for this. Okay, so for this example, let's try to derive all the ranges. Okay, for 1 it is from minus 1 to 3, for 2 it is from 0 to 4, because k is 2, so it is 2 minus 2 till 2 plus 2. Again, this is from 0 to 4, this is from 1 to 5, this is from 1 to 5, and for 4 it is 2 to 6. Okay, so here k is equal to 2. Okay, which was all given in this problem statement. Okay, so if you understand, if you observe carefully, the lowest possible of all these ranges is minus 1, and which is coming from the first element, which is 1. Okay, and the highest possible range of all these numbers is 6, and which is coming from the highest number in this entire array. Okay, so the effective range is basically from the minimum element minus k and the maximum element plus k. This is the effective range in which the overall numbers after performing the operation can actually lie. Okay, so if I plot these ranges on a graph, okay, so the first range is from minus 1 to 3, which is minus 1 till 3, and the second range is from 0 to 4, which I have plotted over here, and the third range is again from the 0 to 4. Fourth range is from 1 to 5, again it is 1 to 5, and we have 2 to 6. Okay, so this is the range after we perform an operation, right? If we choose any number from minus k to k, for the first element, the number can lie between this particular range. Okay, we can choose any number in this range, and effectively the next number we have to take addition. Okay, in order to get the maximum distinct elements, if we choose the least element in the range, then we will have a bigger range for the next elements. Okay, so idea is to always choose a least element for the in the current range. Okay, so for the first range I have choose minus 1. Okay, so minus 1 will be the first element which will get transferred into. Okay, since minus 1 was already chosen, since we want the distance elements to be part of my final array, we cannot again choose the minus 1, right? In the next range, here the next range, since it starts from 0 to 4, there is no way minus 1 is part of this range, so I can directly take 0 as my um, next number after the operation. Okay, if you see here, these two ranges are actually overlapping, since 0 was already chosen in the previous elements range, the effective range for this number, which is 2, will be actually from 1 to 4. Okay, even though the actual range is from 0 to 6, because 0 was already part of the previous range, previous number, the effective range will be from 1 to 4. So I have to choose 1, which is minimum, as the operation after it. Okay, so in general my range, I just generalized over here. Okay, if you see, my range will actually lies from nums of I minus k to nums of I plus k, right? But I have to choose my lower bound in such a way that it is not overlapping with the previously chosen elements. Okay, so if the previously chosen element is this particular variable, let's say in this case it is 0, so my lower range will actually start from the maximum of this and this, right? This plus 1 basically, so previous plus 1. I cannot choose straight away previous, because since we want distinct elements, if we again choose the previous element, that means we are actually including the duplicate element. So the effective range, the effective lower bound, lower range would be the maximum of previous plus 1 common nums of I minus k. Okay, whatever is the maximum, that would be my effective range. Okay, so this would actually will turn out to be like this, and then I will be picking the minimum of this range, which is 1. Okay, since 1 was already chosen, the effective range for the next element would be 1 plus 1, which is 2. The effective range would be 2 till all the way to the 5. Okay, again 2 was already chosen. For this range, the range was from 1 to 5. Since 2 was already chosen, right, the effective range should start from 2 plus 1, which is 3. Okay, it has to start from 3, so it will become 3 till 5. Okay, again we will be choosing the lower element in the range. Okay, it will be 3. Now 3 was already chosen. The effective range for the next element would be 3 plus 1, which is 4, which will start at 4 and go all the way up to this. Okay, here if you see, the effective range is from minus 1 plus 1, which is 0, 0 and 0, both are 0 here, so maximum will be the 0 itself. Okay, so now that you understood how to identify the lower range, lower element of the range, right? So this will help us to identify the lower element of the range. So yeah, this particular approach we will apply to our particular problem. Okay, so I've already implemented it. Okay, in firstly we want all the elements to be sorted. Okay, if we have all the elements in the sorted, then only our ranges will also be in the sorted order. Okay, so okay, the ranges will also be either will be in the non-decreasing order. Okay, so I just defined a variable called n is as the length, and count is basically counts the number of distinct elements. Okay, initially I have kept my previous. Okay, for the first element, okay, there are no more elements in the previously, right? So I have defined a previous as integer minimum, which will help us to identify what was the previous so far. Okay, so which is minimum, and I've just sorted the overall array. Okay, and at any point of time we are supposed to take the minimum of the current range and the previous element plus 1, right? Previous range, previously chosen number plus 1. Okay, so the current range will be nums of I minus k and previous plus 1. The maximum of these two will be the starting point for my range, and it will go all the way up to nums of I plus k. Okay, in this particular range, our idea is to always choose the minimum element in the range. So we will actually taking the minimum of those two, which will give me the current number. Okay, if the current number which you have chosen, if it is greater than the previously chosen number, then only we will assume that, then only we have got the distinct element, right? In that particular case, I will increment my counter and make the current as my previous, and I will simply loop through the entire array. Okay, and then my count will be the total number of distinct elements it will have. Okay, let's try to submit this problem. Yeah, it has satisfied all the test cases, and it is pretty efficient, and it has beaten 90% of all the solutions. Okay, let's analyze the time complexity over here. Time complexity will be that This is actually order of n because we are simply iterating and just doing some basic uh, comparison. So this is order of n, and sorting would take order of n log n. Okay, so the overall time complexity will be the time complexity which is coming from the sorting algorithm, and also the space complexity coming from the sorting algorithm. Okay, if under the hood, if the library uses merge sort, then it would be n log n, and the space complexity would be order of log or order of n. Okay, yeah, this is, we are not using extra space other than the sorting, the space taken by the sorting, right? Yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. I've noticed that people are not subscribing to my channel, but they are viewing my videos. I highly recommend you to subscribe so that you don't miss the content which I'm posting on daily basis. Okay, let's upskill ourselves on daily basis together. Thank you.